Okay, this is question 2 continued. So the student notices that the temperature of the reaction mixture decreases as the reaction takes place and correctly determines that the reaction is endothermic. The student claims that the reaction is thermodynamically favorable at all temperatures because delta S is greater than 0, and the reaction is endothermic. Do you agree or disagree with the student's claim and justify your answer? All right, so you guys have to remember something from class that if, first of all, there's a formula, there's our Gibbs free energy formula. Now, in this formula, when delta G or Gibbs free energy, when that is negative, then the reaction is thermodynamically favorable at all temperatures. And that only happens when delta S is positive and delta H is negative. So when the reaction is exothermic, that is more favorable than endothermic, because think about it, endothermic means absorbing heat, so that's not favorable. That actually takes more energy to do that. So because my entropy is positive, but my reaction is endothermic, not exothermic. So I'm going to just change this to endo to match this reaction. So that's not going to make it favorable. So do we agree with the student's claim? No, we disagree. And we disagree because we don't know what we disagree because our two variables are contradicting one another. The entropy is okay, but the enthalpy is not okay. So we can say something like this where delta S is favorable, but delta H is not favorable. And as a result, we'd have to look at the temperature to see if, because that's a variable we haven't looked at, we'd have to look at the temperature change to determine whether or not delta G will mathematically become negative. So delta S is favorable, but delta H is not favorable, and this may result in delta G being positive, which is not favorable. Okay, and once again, you'll have to look at the answer key to do your wording a little better than what I'm doing, but I'm just trying to talk you through my brainstorming and strategies on how to solve this question. And then finally here, next the student investigates the acid-base behavior of the maleic acid. The student notes that it is a diprotic acid, which means there are two dissociations. Diprotic means there's two H ions or two hydrogens, and that it can dissociate twice. Okay, producing, as you can see, your hydronium in this Bronsted-Lowry equation. So Ka1, this means the first dissociation. And then Ka2 just means the second dissociation, so the removal of a second hydrogen ion. And as you can see, they're both, these K values are both weak, like they're both 10 to the negative exponent. So both of these represent weak acids, and they will favor the left side of the reaction. And we'll produce very little products here. But we don't need to know that to answer this question. It says to calculate pKa2 of HC4H2O4 negative. So you have to use the formula that the pKa equals negative log of Ka. Okay, so for this one, this is actually not too difficult of a question. All we have to do is plug this into this formula. So the Ka2 value is this one. So the pKa will equal negative log 8.5 times 10 to the power of negative 7, and that will give me an answer of 6.07. All right, we'll pause it there, and you can go to the next video to see the next questions.